Hi, and welcome to Let's Talk Safety. I'm your host, Dylan Sutherland from Protector Safety Gear. Throughout this series, we'll be interviewing industry experts to provide our audience with valuable insights on various categories of PPE. Topics will range from selection and standards to maintenance and care. This should ultimately assist you in selecting fit-for-purpose safety solutions for your site. From these discussions, we will create resources such as Toolbox Talk downloads and blogs, all of which will be available on our website, www.protector.co.za, for download. Welcome back to another episode of Let's Talk Safety. Today's episode is really exciting. There's one point from a work at heights point that we get to discuss serious considerations that we need to be taking when we're talking about lifelines and making sure people are safe when they're working on a roof or working at heights connected to a lifeline. The second point that makes me excited is we get to spend the day with Stephan van Heerden. Stephan is somebody who's, from my perspective, grown from literally green, not knowing anything in safety, being able to learn and understand how to keep people safe, specifically linked to work at heights, but more importantly, actually cares for the person and wants to ensure that they stay safe when they are in a full risk position. So Stephan, maybe you can give us a quick introduction as to who you are and how that passion for keeping people safe came about.
Yeah, thank you so much for having me, Dylan. I think the passion for safety sort of aligns with my personal values as a person. And I think Protect has also just been a really great environment to work in, where it's allowed that passion to grow. I think it's very rare that people get to work for a company where their personal values align with the values of the company. So I think that's pretty cool, and you guys have really helped me develop that. So thank you.
Cool. Two-way street, so that's very awesome. Cool. So the way we're going to structure today is slightly different. So we're going to rather have a couple questions that we've experienced in the field, and Stephan, obviously being exposed to the field quite a bit, will have really valuable insight for that. But those questions, I think, will also help the audience better answer questions that they're probably asking internally and not really understanding how to get to a sufficient answer to make sure that they're allowing fit-for-purpose safety, making sure that they keep the people that are working in a high-risk position safe. I think before we get into those questions, though, there's a really high-value conversation we should almost set the tone with. Quite recently, you've been on a bit of an expedition, taking this vehicle we call the S-Wagon to site, trying to educate and create a lot of valuable knowledge that is probably overlooked from people that don't get too deep into work at heights. For me and you, we're quite lucky. This is our day-to-day. We discuss this on a daily basis. Not everyone gets that. So I think let's paint the picture. Let's maybe just give an idea of what the S-Wagon is. There's three critical things that I think come from it. Will you explain to us the main message that you try get over to the people on the site regarding the kind of forces the body can sustain before it becomes fatal?
Yeah. So what we do is we take the S-Wagon on site and we do a drop test with a weight of about 100 kilograms. And we'll drop this weight with a rope, with a shock absorber, and then with a self-retracting lifeline. So we'll do 3 drop tests for the customer. And what we aim to educate the customer on is the forces that's involved in a fall. So the first drop that we do is with a rope, and we drop it at about a length of 1 meter. And bearing in mind, a rope has about a 10% stretch, a 5 to 10% stretch. So it does absorb some of the forces, but it doesn't have the same shock absorber which a lanyard will have. It doesn't absorb that shock or decelerate the force. So we, with about a 100 kilogram weight dropped at about 1 meter, we notice that the forces can get up to about 1,000 kilograms.
And what does that look like in normal? I mean, 1,000 kilograms, I can imagine lifting 1,000 kilograms. I'm not going to do it. But on my body, what does 1,000 kilograms do?
After about 600 kilograms of force, anything higher that the human body experiences, you can die from. So at 1,000 kilograms of force, you definitely die. The human body cannot withstand that amount of force. So if you can imagine you falling and your harness and your lanyard is pulling in the opposite direction. So it's two forces pulling in the opposite direction, and it's sort of like ripping apart your internals.
And then that's that over that 600 kilograms, it starts becoming basically fatal from an internal point.
Yeah.
I mean, probably you're not even going to see the damage.
Yeah.
But over that 600 kilograms starts creating internal damage, right?
For sure. Yeah.
So, I mean, and that seems like it's clearly explained. I mean, do people react positively when they actually see that? Because your demonstration puts the number on the screen for them.
Right. So before I give the guys the number, I usually ask them to guess what the force would be. And a lot of people guess, 100 kilograms dropping a meter. Usually the guesses are around 300 kilograms. And when I tell them that it's 1,000 kilograms of force and they can clearly see that, there's a lot of shock. The guys are...
Cool. I just want to reiterate, you said that drop is 1 meter.
1 meter.
So that's 1 meter, 100 kilograms of force dropping. The second thing, and the reason I want to highlight that 1 meter comment is, I don't know what you experience, but I experience a very different understanding on sites when they talk about when should we be connected when we're working at heights. What height is generally seen to be dangerous in industry?
So most of the sites we go to, people only start looking at working at heights equipment when they're working above 2 meters. So that's when they think that you're in a risk. But as you guys can see, we drop you a meter, if you fall a meter, you can die from just falling.
And it makes sense. I mean, if you think about any sports, if a soccer player or a rugby player jumps up to collect a ball, they're not jumping more than 1.5 meters.
Yeah, yeah.
And if somebody takes their legs out from under them and they fall, that's a serious human physique that is getting seriously damaged.
Yeah.
Now we're talking about somebody that's not training to take impact or not training to do that. So I think it's a vital. So distance, we shouldn't be considering, right? Less than 2 meters or more than 2 meters being the danger point.
Yeah. So that is, it can become fatal even from 1 meter. And I think that's the point that we want to get across. And again, you don't decide when you're going to fall. So most falls are from slips and trips. So you can really fall in quite an awkward position as well. I mean, you could fall, you could slip and you could break your neck falling 1 meter.
Yep.
Or you could die, if you fall in the wrong way. So I think that is something that industry perhaps needs to start looking at.
Cool. So that's the two messages that get brought across. So we speak about the weight, the maximum weight or force that the body can withstand without basically succumbing to injury.
Yeah.
Then the second one is the distance. The third one is there is an obvious need that if there's a force higher than 600 kilograms, which we can see happens quite rapidly.
Yeah.
How does it get removed from the system? Because it's not just the human body. There's other elements to it. There's an anchor point. There's how does the force get removed from a fall safely?
So that's when we need to start looking at shock absorbers. So the lanyards that we use, all fall protection equipment is designed to keep the forces below 600 kilograms. And it's all tested to do that. But
there's obviously a payoff. I mean, to keep the forces from 1,000 kilograms, get them lower than 600.
Right, yeah.
What do you have to sacrifice?
Well, most of the time you've got to sacrifice the fall length, the distance that you're going to fall, because you've got to decelerate that force somehow. And that's why we use shock absorbers, because shock absorbers decelerate that force and they will deploy. So that's usually...
And in this demonstration you do on sites, you've spoken now about the 1 meter of a rope creating 1,000 kilograms.
Yeah.
If you had to drop that same force or the same weight on a 1 meter lanyard with a shock absorber, what would that deceleration look like? What would that distance look like of the shock absorber deploying?
Yeah. So it obviously varies where you would connect that shock absorber. If you're connecting the shock absorber at your feet and you were to fall, more of the shock absorber would deploy because it's got more force that it needs to arrest. But if you're connecting on top of your head, generally not the whole shock absorber will deploy. So in those cases, we see about 10 centimeters, 15 centimeters that the shock absorber will deploy.
Okay, cool. So yeah, painting that picture I think is essential for the the rest of the conversation, because right now we're seeing a huge need of knowledge, a huge amount of risk happening on sites when it comes to installing Lifelines, because one, it's a costly exercise.
Right.
Being able to create a system that keeps a human safe means that system needs to withstand those forces. It needs to dissipate the energy if there's severe energy in the fall. It also needs to make sure the human doesn't hit the ground by creating too much sag. But there is a cost factor, and cost is obviously something that sometimes determines the decision, unfortunately.
Yeah.
So I think let's go through the questions. We've got a couple that hopefully open this conversation up a bit. The first one that I wanted to put on the table for us to discuss is, does a Lifeline need to be certified?
Yeah. So that is a good question. I was actually on site recently, and a customer asked me what certifies a Lifeline, or what makes a Lifeline certified. Oftentimes I'll get on sites and you'll just see, guys sort of make a plan. They use D-shackles and a cable, and they call that a Lifeline.
Yeah.
Not understanding that it needs to be compliant to the EN795 standard. So I think maybe we can get into that and what makes a system certified.
Let's get into that then. I mean, you've made an example of the D-shackles. If the D-shackle, for instance, was certified to an EN795 standard, would that make the system compliant?
Right, so not just one component can be certified, the whole system needs to be certified. So you can't just get one single D-shackle that's certified to an EN795. You need to look at the entire system. So the shock absorbers that's involved in the system, the anchor point itself, everything needs to be compliant to the EN795 standard.
Okay, that makes sense, because I mean, if a fall happens, it doesn't happen on one component, right?
Yeah.
That shock force is moving through the system.
Right.
Effectively putting every single component under those massive forces.
Yeah.
And as a system, the entire thing would need to be certified, in this case, to EN795 Class C.
Absolutely, yeah.
Cool. And what to the installation? I mean, I can go buy a system. I can give you components this is a components that is certified now to EN795.
Yeah.
Can I just go take that and go install it? How do I make sure that that's actually done appropriately?
Yeah. So you need to be certified by the OEM, the manufacturer of the equipment of the Lifeline. They need to give you guys training, and you need to have a certificate that shows that you have been trained, that you know how to install this equipment.
Wow, that's simple. I just bolt it on. I've seen it on site. We just tie the thing on the anchor point. I mean, what's the need for that?
Well, remembering that someone's life is at risk here. If something goes wrong, the OEM's gone through the necessary steps to make sure that their system complies and it's EN795 compliant. That responsibility then falls onto the installer. The OEM's done their part. So if there's any fault, the installer would be at fault if somebody was to die on that system.
Okay, that's understandable. And I mean, they go through serious testing and making sure they're adhering to standards.
Yeah.
That last component of installation needs to carry that.
So serious, yeah.
That's then the OEM needs to effectively sign off any single person installing those systems.
For sure.
Okay. The second question that we quite often, we see getting asked, so I don't know if it gets answered appropriately, is, can I run a cable through a Crosby clamp and use that as a Lifeline?
Yeah.
I don't know what your viewpoint would be on that.
So definitely no. It's a big no-no. Again, the whole system needs to be compliant to the EN795 standard. In Europe, they've actually started stating in the EN standard that Crosby clamps cannot be used. Obviously, in South Africa, we are a little bit behind, but we are moving towards that. So we do adopt the EN standards, but we haven't adopted the latest EN795 standard.
And I think it's vital that we just quickly touch on that, because at a SABS level, yes, we adopt the most recent. There is an issue where we cannot adopt an addition to a standard. And the EN, the latest 2012, EN 795 2012, states that it's only for one person. So South Africa did make the decision from a SABS level to say, look, we're only going to adopt the one before that because that allowed multiple users. But gravity doesn't work different in Europe to what it does in South Africa to what it does in the States. And I think that is vital, and that point is serious. I mean, if you're going to make a specific comment saying, look, you can't use a Crosby clamp, whether or not it's adopted in our SABS standard, that needs to be seriously taken or looked at.
And the other factor is also Crosby clamps are generally used in lifting. So they designed for a static load. When we're working with fall protection, we're working with a dynamic load because someone's falling. So we're also not using the Crosby clamp as it was intended to be used.
Yeah, I think let's just pin that point a bit, or focus on that point a bit more. You say that a Crosby clamp is used for lifting. Explain that to me.
So it's used in lifting operations. If you need to lift an object and move it, you would hook it up to an anchor point on the system, and then you'd move it and lower it again.
And so what's that difference? What's the difference between that lifting then?
Yeah.
You said it's static.
Right.
Versus
a dynamic load.
A dynamic force, which is the fall, right?
Yeah.
What is the fundamental difference there?
So with static load, the load's not changing. With dynamic load, the force is increasing, as we demonstrate when we do these drop tests.
So as a simple way to look at it, what I'm understanding is, in a lifting operation, there would almost be no slack in a system.
Right.
Because it would be under tension at all times while it's moving.
Yes,
Versus a dynamic load, which is, there is slack because that's your lanyard, right?
For sure, yeah. Your lanyard would have slack.
And that then accelerates and creates this massive force where a static will never ever shift, or it won't change the weight.
Yeah.
Okay. When we talk about the static, I mean, what would happen to something which is designed to withstand a static load if we applied a dynamic load to it? What is the potential?
Well, the system itself can fail. So, for instance, with the Crosby clamp, you've got a wire running through both ends, and the Crosby clamp is pinning it together. If somebody falls on that, it can actually pull the slack out of this wire, and the entire system can fail.
So basically pull the cable straight through the clamp. And then allow for a disaster, because
100%.
Then you don't have a connection point. You're connected to nothing. So the one, I don't know how common it is anymore, but I used to experience it basically on a daily basis if I went to a construction site, was we would, the client would run a cable. That cable would be connected 20 meters apart from one another, each anchor point basically connected to Crosby clamps. There's two things there. The one is, you've just made it clear that it's for lifting, so there shouldn't be any dynamic loads on it.
Yeah.
But the very concerning part for me is there's slack. There's slack in the system. What happens with that slack? So if you're running a 20-meter lifeline, but there's 25 meters of cable, what is the effect if somebody falls on that?
So first of all, you're going to fall an extra 5 meters in that case, because you've got an extra 5 meters of slack.
And we've just spoken that 1 meter at 100 kilograms creates 1,000 kilograms, right?
Yeah.
So let's be safe and times that by 5. Yeah. So we're adding another 5,000 kilograms of force on the system per person.
Per person, yeah. So with that slack, obviously the person's going to fall a longer distance. Whatever they connected to, if they connected with a shock absorber, it's got to arrest so much more force, and it's going to increase their fall distance. So there's the possibility that they might hit the ground, and there's also the possibility that the anchor points could literally just rip apart because that force is ridiculously high.
And it obviously gains more force, I mean, we're being quite conservative to say 5,000 because we're just taking 1 meter and timesing it by 5. The longer a weight falls or is in motion, the higher the force it creates.
Yes, yeah.
Because it's building on itself.
Yeah.
Gravity works to the power of gravity, so it's exponentially higher. Okay, cool. So are you saying then that having a line with a Crosby clamp on the end, I mean, are we definitely comfortable that is not a safe operation?
Not safe at all.
And when we talk about that distance, we talk about the 20 meters. The S-Wagon, when you test the anchor, when you test the dropping force, do you test it on a line or do you test it on a single point?
So there we test it on a single point, on a single anchor point.
So on a single anchor point. Yeah. And what do you think would happen if instead of having a single anchor point, we run a line of 20 meters and you had to do that test in the middle of that? Do you think the end points would still read the same 1,000 kilograms?
So that would be exponentially higher on those end anchor points, because every time we move the force away from that anchor point and we've got an arrest of force, that force just goes through the roof.
And I mean, you don't get to decide which anchor point sustains the majority of that force because it would probably be the one that is closer to the fall, right?
Right, yeah.
Which then adds another element of danger because if you're too close to one side, most of the force is going to be shifted to one anchor point.
Yeah.
Okay. And the cable itself, I mean, how do we know that that's safe, or is that still part of the entire system? It needs to be certified as a single unit.
Yeah. So again, that entire system, the cable, the anchor points, the shock absorbers, everything forms part of that Lifeline system, of the EN795 system.
Cool. So I think the big message is no using Crosby clamps.
Yeah.
If we fall on it, I mean, I think even to the point of if you manage to get all the slack out the system, there's no ability to remove the shock, right?
Yeah.
And that then leaves somebody exposed if they do experience a fall on.
Yeah. So just to add on that as well, we've been in scenarios where we've got the base plates, the cones, the shock absorbers. We've got everything except the cable. And you'll get questions from the client, but can't we just use any old cable or any other cable? Does it need to be that specific cable? And the answer is always no. We need to use this cable that's supplied by the OEM because that forms part of the EN795 system as a complete. So we can't just install half of the system and then the other half from a local or just from, a lifting company, just get a steel cable from them and install that. We need to wait and get the proper cable for the system.
Fantastic point. Thank you for joining us, and I hope this episode added value to you. If you are experiencing any safety challenges on your sites and require any additional information, please do leave us a message on LinkedIn via Protector Safety Gears page, or alternatively follow the link below and share a message with us because maybe it can create value or a valuable conversation for future episodes. Be sure to also follow us on LinkedIn. There will be some valuable information shared from today's discussion.